Hello, everyone. I want to record this video because in one of my classes in the course of Introduction to Machine Learning, I was taught one concept to how to deploy a model in practice. And that session was recorded, but for one difficulty that happened, that session, was not achievable. I don't know what's happened, but because of that, I made my decision to just record a video for my students and also for who are interested to this concept that let's say you have one model, simple classical machine learning model, and you train that and your model is ready, your model performance is good, and you would like to serve that model. So because of that, I just put a little bit effort and I created one Python module that can give us one level of abstraction that help us to, at the time that the model is ready, we somehow be able to just save that model and reuse it to the, some famous framework like a FastAPI and, use that, getting the prompt or input of the body of the API, HTTP protocol, REST API, and put the input in the body of that request and just transform it, fit it to the model, just as an input, put it to the model and give us the prediction value. So long story short, I would like to show you. I'm gonna go ahead and share my screen. So I will share my screen, and here is the page of the module that I created. I name it mlModelSaver, and because why I put that name for that, because basically the concept of that, how you can save a model in an easy way, okay? And I mentioned make life easier for saving and serving ML model. But also you can just assume that this name can be something like a simple model, simple machine learning, simple ML model registry. It can be some kind of a registry. And this project is, in a earlier stage, and I will just working on that to make it better to support more model. But if you are interested to, knowing about some kind of the competitor of that module, basically my module is a simple one, but there is a project for MLflow that I believe Apache is behind of that. I'm not sure, but this one is a one open source project that will do end-to-end machine learning and generative AI tools for, tuning the model, versioning the model, serving those models, and so on and so forth. So this project, it's going to be a very big project, and if you would like to using that, that's a good start. But there are lots of documentation about that, and also if you would like to use it in a production way, you have to have some kind of expertise to how to deploy entire MLflow, how to serve it, how to manage it, and also you need a specific infrastructure to handle that. But for very abstract one, I just created that one, and I put some useful link here, which is one of the link is just if you open that, you will come back to that page. Another link is here is the GitHub repository that the model is just, the module is just there. And if you would like to know about that, the entire module is this file. And this file is basically has some sort of functions. And on top, there is one class that whenever you construct that class. At the time that you construct that class, it will be give you tools to save or load the model, or load the save before save the model, and you use that. So I'm gonna just come back and give you some example about that. First of all, before the example, I would like to show you some kind of demo. Basically, I just deploy the changes that I create to one Heroku server, and I just attach it to my one of my subdomain to help you. And I'm just using the FastAPI for this, and I just created some basic endpoint to give you an idea how that system is working. There is a one endpoint that is gonna show me the current list of saved model. And if I just try it and just execute it, you know, basically it's gonna be show me the list of the models that I already saved in my, you know, API endpoint. So all of those models right now are accessible. So basically I just trained those models, I saved them, and I'm using the library that I create. And just give us the certain models that is there. So I'm gonna just copy one of them. And in the next endpoint, if you would like to just know about the information about that model, feel free to put the one of the model name here and just execute that. And after that, it gives us some information about the current saved model. Basically, this model is, you know, the name is based on the, you know, versioning and so on. That this model basically is going to predict the sales based on the temperature, advertising, and discount. And under the hood, how that model is working is based on the one Jupyter notebook that I'm going to explain to you, but I would like to just show you how it's going to be working. So it gives me that some information that the model is trained by the SM library, and it's used the OLS like a linear regression for that. And if you would like to get a prediction about the model, you need to pass the temperature in the float type, advertising in the float type, and discount in the float type. And then after that, once it's there, it's going to be return the sale in a float type as well. So I'm going to copy that and just come back to the last one, which is a predict endpoint. And I'm going to just try it out. I will put the name of my predictor model here, and there is a discount value, advertising, discount, and temperature value. Is that correct? Yes. So if I just execute that function, it basically should return the one predicted based on the trained model, and it will be return the value that I was looking for. And based on my model, the prediction is that. So we are right now, we are not talking about the performance of that and so on and so forth. The aim of that is how we can train a model, simple model, save it, and using it into the, you know, real API production. And, you know, that's a real API. For example, there is a CURL example. If I'm just going and open one of my terminal, and let's just open my terminal here. And if I just run that, also you will see that's going to be return the value of that. So because it's a standard, the FastAPI is the standard one, basically it's just sending the one post request here to this endpoint, and it's going to be send a one body like that. And the body basically needs to have the name of the model that you are looking for that. And if the model is already there, it's going to be return a value. And then you need to basically send the input to getting the result of that value. And the way that is working is based on the data framework. For example, I can just also predict 3 times of my value. Let's say another one that advertising is 16, and another one is 17, and the discount is 30%, for example. If I execute that, you will see basically it will be return 3 value based on the input. So it can be helpful for the time that you would like to just, batch predicting your input as well, and as a one API layer. Okay, long story short, I'm gonna come back here in the documentation of that project. I put some high level information. There are examples here. If you open those examples, one of the repository basically contains some useful notebooks that how I just use that, which is I'm going to explain during that video. And also this is the one project, that FastAPI project, that this FastAPI has those three endpoints that I just show you: the model list, the model information, and also the predict function. So how it's going to be. And that project is, very simple. And I just use that to just show the use cases. Feel free to, clone that repository, create more advanced tools on top of that at the security level, and so on and so forth on that project. Anyway, this is a FastAPI. If you are interested to know about the FastAPI, the FastAPI is one of the, game player for the serving, using the Python to serving the API backend with the Python language to creating the web server and, handling the request and do some process on top and, return the response, and just working for the building the most use case of that, building the RESTful API. And the learning curve of that is very easy. And all you need to have some basic understanding of the web network protocol, and also you need to know a little bit about the HTTP protocol and the REST protocol. And once you have the documentation for FastAPI, is straightforward, and it's one of the Python project that I love it. And whenever I would like to create a one Pythonic API, for sure I'm going to use the FastAPI. The competitor of the FastAPI is Flask or Django or other frameworks. The Flask concept also is the same as FastAPI, but the FastAPI has a better abstraction, and there are lots of good examples that you can use it. Anyway, the FastAPI, I just use that for my example of using that FastAPI. And if I come back to my examples, here's the demo I just show you that demo, and I just put some kind of the links for every single demo of that. So how we can install that module? It's easy. I will just scroll a little bit. You can easily install that module of the mlModelSaver. At the time that we are talking right now, it is on the version 1.0.26. which is for sure is going to be add more version because it's in the earliest state of that. And right now it's only supports 3 way of the model serving. I just put some documentation here. Let's just come back here. The supported model right now, I'm just, supporting the SM-OLS. I am supporting the SM-Logit. And also I am just, supporting the scikit-learn, Nivers, KNN basically. So that's a supported model, but for sure in the future I will try to add more model supporting for that. And basically there is another one, normal predictor function. As we know, the OLS one is going to be, that has a one built-in predict function that is going to be called for us, and it will be returned there, for the dependent attributes based on the linear regression is going to be sent. The Logit one has a predict function that's going to be return us the probability values. And also KNN has one function that the normal predict function is just returned based on the cutoff of the 50%. It's going to be send the true or 1 or 0. But for the aim of that, of the serving the model, basically we are looking for the probability values. And for that, I just use that to predict probability. And also under the hood, there are some kind of if statement. If the model is that, and call that one and just, do some kind of the abstraction to just return there some value. I'm going to show you. So for using that MlModelSaver, is the step is easy. Let's say that you have one trained model, which is here. So this is your, imagine that this is your model, and you trained it, you fit it. Basically, it's most of the ML, statistical ML. It's not the training and testing thing. Let's say you fit your model, and your model is good in the performance, and you would like to save it. All you need to call first of all, you need to import the ML modules instance. I'm gonna put some example during that record. I see there is nothing. I have to just add a better documentation here. But let's say you will just construct the mlModelSaver, and then there is one method that you can call to export the model. The first argument that you need to pass is the fitted model. And also after that, you need to pass one dictionary to that, and those values important. The first one is a model name. You can put whatever model name, and at the time that you save the model name, the system will just save based on that with the model. So then the model name should be, all attached together, and should not. It's using as a one Python variable, so please do not start with the numbers, or also some reserved function name for model saving, but you can just save the model by whatever other matters. And then you can add a description to your model, and whenever you put the description at the time that you calling the mlModelSaver, the description also will appear for you. And then you need to put the model type. As I mentioned, right now it's only 3 types of the model is supported, but I'm gonna go add more model supporting for that. And then the input type that the model looking for. So you need to, for example, for this case, the inputs value as a dependent attribute with the temperature, advertising, and discounts, and the type of that is just flow. For now, the type value here I put is just for information, but in the next version of that module, I'm gonna go ahead and also add more strict way to, if there is the type that you are sending, you are fitting, you would like to predict if the type is not matched with the type of that you are sending, is gonna be through some error to just having a better understanding. And also the mlModelSaver has a one good thinking about how we can serve a model. The model by itself, sometimes if it is a linear regression, that's important. That's easy. That the data frame that we just put feed as an input, it's the data that we would like to using to get the prediction. But sometimes our model is just based on some transformation, the data frame is changed, and the data frame, the data frame should use for our system. So basically what I create a one key in the dictionary as a config that you send. I put it the transformer, and basically the transformer is a Pythonic function that you will create it at the time that you're gonna training your model, or at the time that you are going to you calling the predict. And under the hood, once right now the transformer here I just put basically that this transformer is only at a constant value at the first column of my data frame, because the OLS by default, if you would like to OLS, the OLS is not using the same as the scikit-learn linear regression. The OLS, whenever you would like to get the intercept of your value and also do your scope, you need to just also pass the one constant value which has a value of 1. So on that function as a transformer, like a simple transformer, I could say add const column to the first column of my data frame. So this is a simple transformer, and we just pass the transformer, and then we just need to specify the outputs. And the outputs is basically for the most of the statistical machine learning dependent attribute. It's going to be a one value, but because in future I'm gonna, support more models, and maybe at some point we will have multiple dependent attribute that we would like to just predict. So it's gonna be help us to add, more outputs that we are looking for. And then you can just easily create your data frame based on that, the temperature, advertising discount, and you create your data frame at the time that you would like to using in the Pythonic way. So basically you can just call loaded model. Whenever you just say, export the model at the time under the hood, it will be returned one instance of the exported model for you. I name it loaded model, and you can just use that loaded model, and there is a one method, one custom method that is going to be under the hood will be there. And this model is, I put it mlModelSaver predict. And this is a predict that comes from the configuration for the supported model. Where is it? Here, I think. I put, yeah. For example, for the supported model, it's use the OLS predict function. For logit, it's use the OLS predict function, and for this KNN, it's gonna be use the KNN cluster scikit-learn KNN classifier with the predict probability. So under the hood, this function, which is I show you mlModelSaver predict, is used that. And as you see, if I just use that, the normal value of the predict, it just return me the only value, and I have no idea what was that value. But the beauty of that configuration for my model, if you call that model with the same data frame, it will be return the same value for you, but it will be specify the name of the, the dependent attribute that also you are looking for. So that's it. And I believe I just explained most of the thing. I would like to go to just show you some example. Basically, I created 5 examples that it's going to show us, give us how we can just use that, and how in real world that we can just using that model. So I'm gonna go ahead and just use this repository, which is mlModels deployment, which is one of the repository that I am using that module. And this repository, it has the FastAPI as I explained, and there is a notebook project. So I think it's already opened in my computer. Let's just find it. It is in my VS Code. Yes. So this is my ML model deployment. And if you see that the instruction of that, there is a models folder. I didn't, give you that. What is that? I'm gonna explain to you in a bit. And I have some notebooks. That notebook is not serving in the cloud. The notebooks concept is only at the time that I would like to working on, just training some model and so on. I will use that notebooks folder, and once I'm good with the model, I'm gonna save it to the models folder. And then there is a VM with the things that it's not, committed, and it's not in the GitHub repository. If I come back here to show you, you see that VM file is not there. But there are the other files. One is the git ignore. The git ignore, I just use that to not commit whatever I don't want it. And another one is about the history command, which is don't use it. This is the main file that's serving the FastAPI project. And as I mentioned, it has only 3.4, which is one of them is hello.json. That means if I just go and put the ml.json jafari.com, it just show us the hello.json as return. So basically it has 4 functions, 4 endpoints that those endpoint has attached to the specific functions, and each function will do. But under the hood, it has imported the mlModelSaver, and then it just created one instance of the MlModelSaver, which is I'm gonna explain how it's working. And you need to just put some high-level information for that to just work it. But note that whenever you put the base relative path and put the model name folder, it's going to use that folder as that. And right now I'm committing my, all of my models to the repository. But in future, once I just added better things on top of that model, what I will just do, I will create some kind of configuration here. For example, if we would like to use the S3 as a storage server, storage management, so we can just put the, for example, S3. It's not right now, it's not functional, but I just want to give you some idea. S3 endpoint, and it should be some value, which is ideally comes from the environment variables. S3 access key and the S3 key ID and the secret key. So it's gonna be allow you to just using the Amazon S3 or other S3 compatible, sources that you can just do that. And once you have that configuration, you don't need to using the model folder in your repository, and you don't need to just commit it. But for now, for having the just this the library and module is just working, and we don't have that option yet, but I just give you some heads up in the future. I'm gonna just add that functionality as well. Instead of saving our model in our computer, we can just save it to the S3, and whenever we need it to the serving, it is going to just download one time to the at the runtime, and it will be used that file as a file storage, but only it's going to be downloaded. But you can just think about that. If we have that architecture, we can just use it in the distributed way. Let's say your FastAPI production endpoint is going to be served to the multiple places, and the endpoint of that call from different. At the time that you call the endpoint, it is going to download it first, your model, into the runtime, and it's going to be there. And for the next call, you don't need to just download it again from the S3 bucket. And it just gives you also some kind of not paying too much of money for the clouds and usage. So that's the thing that I'm going to add that. But that's the model that we will have. But before going to the API part, I do like to just show you how the notebooks working as an example. The examples I put here, all of them, there's this 5 example. If you just click on that, basically it will be open the same repository, and there are some Jupyter notebooks that you can just run to save the model to see how that things work. And I will, during that video, I'm gonna just also show you, because that's gonna be also helpful, that how the entire system is just working. So I'm going to come back here, and first I'm going to just delete all of the models in my folder. And there is a README file that I put. Basically, if you would like to use that, there is a requirement txt file. And if you would like to use in a Pythonic fashion, and you have a multiple project of Python, and you have a multiple different Python version, the idea of creating a virtual environment can help you to just using that. So let's just remove that virtual environment as well. I'm going to remove that rm-rf v. So basically what you need to just using the step for the README is, I'm using the pyenv, and right now I'm using that version of the Python, which is if I just do put the Python -v Python, it just gives me the version of the Python, which is 3.12.3. And I think there's a new version is just released, but at the time that I'm recording that, it's the most latest one. And then once you have the Python installed, let's ensure that you have installed the virtual env and your global Python version. So I will just go ahead and run that as a virtual environment, which is already satisfied. That means my Python project is ready. My virtual env is ready. So after that, once you install your virtual env and your Python path is there, if you run the virtual env, basically it just created one venv folder for you that has a minimal Python current version of the Python. And if I just go to the bean, you see there is an activate, and there is a basic Python command line and the pip command line. And that's it. So if I just install that, basically just create a one Python folder for me that I can just use it, and it can just isolate myself and my command line from the other packages and Python things that I need. And I'm using my computer. So I'm gonna go ahead and activate that Python project. Right now, you see if I put the which Python, it just show me that my installation Python is in the py-env and in this folder. But if I would like to just use that Python, the command is source, and the command is in the venv bin, and I would like to source this activate file. So I'm gonna just source that venv bin and activate. So if I just do that, you see in my ZSH command line, on my ZSH command line, the one venv just appear. And right now, if I just put the which Python again, it is just showing me a different way, different place. That in my computer, the project is in that place. And the Python right now I am using, the Python environment or runtime that I right now am using is in that, based on that, my local file system. So, but because I remove my virtual env and that's it, my Python project doesn't have any dependency. If you would like to just be able to attach working with the notebooks and also some other libraries, there is a one requirement.txt that I provided here, and I will keep update that if the version is changed. And all of the dependencies that right now we need to use for not to having the FastAPI, Jupyter Notebook running, the NumPy, Pandas, Matplotlib, SM module, scikit-learn, or so on and so forth. All of them is just saved here, and I can easily just install it. And the command line, I just also put that. You can just put pip install -r, which is I'm going to just install based on the requirement, that the requirement txt is there. So I can just go pip install -r requirements.txt. And it is going to just install the dependencies. And it takes a bit of time to install all of the dependencies because there are the most module that I'm using is FastAPI, UV code, Jupyter Notebook, Jupyter Lab, Pandas, NumPy, SM, scikit-learn, Matplotlib, and some other Pickle, which is for the Pickle one. That at the time that I'm just saving, I'm just using the Pickle. The Python has their own Pickle, but it has not some kind of the good functionality. I'm just using the deal as the one function that using the same concept of the Pickle. During that, I'm going to explain how things is working, but yeah, I'm just using the deal one. Okay, so once everything is ready, okay, so I put another command that I would like to run my Jupyter Notebook. So I would like to run my Jupyter Notebook, but before that, to running my Jupyter Notebook, because all of my notebooks, I would like to organize my folder. All of my Jupyter Notebooks is in this folder, but at the same time, I would like to sometimes come to use my root of the project as some kind of function I would like to just write and just use that during my runtime of the Jupyter Notebook. I do recommend you at the time that you run that Jupyter Notebook, just also mention to the system runtime that my Python path is not only the current Python path, also add the current folder that I am here, which is the pwd is that this folder. Also add this current folder as a Python path. So if I create a one function or module, I can easily just able to just import it into my on all of the notebooks. And then I will just, because the Jupyter is installed, the notebook is installed, I will specify to just run that Jupyter notebook based on that folder with that port number. So I'm going to just copy that entire piece of code and I'm going to run that. So once I run that, basically you see that the Jupyter notebook is just open to this notebook folder. And it just shows us those folders. And if I come back to the project again, all of the examples that I put is example one is that this one. So if I open the first example of how we can just say our model, it's going to show us. So before starting, I just show you that I deleted all of the models from my model folder. Okay, so there is no model. First of all, for just using that functionality, I would like to just create a one transformer function, which is I would like to use a simple linear regression with the OSM SM the module. So I would like to just use, and I just create a one simple Python function that basically accept as a parameter or argument one data frame, and then just create another data frame, and it will be add to the first column of that. It will be added one column which name is const, and the all value will be one. So that's the entire thing that function is. I'm gonna run that, and then I just this is some kind of analytic things that I just want to have having a one simple linear regression to working. And I have a one data set in my Dropbox, and it's just shared. And if I just run that, what's happened? mlModelSaver port. So what is wrong? mlModelSaver is not installed. Just ensure pip mlModelSaver. Why it is not running? Reload. Okay. No, my tool. mlModelSaver. Let's just come back to check. VNV library mlModelSaver. mlModelSaver, and it is there. So it's supposed to be there. Let's just check. Maybe something wrong in my computer. Main file. It is not there. Okay. mlModelSaver, it's not there. I'm gonna just pause that video. I will just fix that, and then I will just I need to just do some troubleshooting. I will just pause the recording, and once the problem is solved, I will come back. Okay, so the problem was that because before just starting the recording, I used my terminal, just used that environment that I just deleted, but the runtime was open. I had to just kill my terminal and just rerun that. So I'm gonna just exit this one. So I'm going to close all of the terminal. I'm gonna open another terminal. As we discussed, we need to just activate my source. My Python runtime, it's going to be venv and bean and activate. And then I will just go ahead and run my Jupyter Notebook lab again. So let's just close all of them and just use one of them. Okay. So I'm going to open the first one. I explained that this is a function, and then I'm just importing the pandas matplotlib for my analytic to just show some diagram. Also, I'm importing the ML model, which is right now if I'm running, you see it just successfully import that, and there is a function helper. I think we don't need that one because the function already there. So I'm gonna just run that one. Let's just reset the kernel and just run it again. And then also I'm importing the stat models, which is SM. All the time I mention SM, which is a stats models. So I'm just open that. Some part of that is only some kind of information. But for my data frame that I am working on it's about one data frame that has a sales, temperature, advertising, and discount. And I would like to just fit a simple linear regression. Those are my independent attributes. temperature, advertising, and discount, and I would like to just fit a one linear regression to just give me the regression, linear regression for these three independent attribute, and just explain me about the dependent attribute. So the normal way that we need to just using the OLS, basically we can just use the SM OLS, and we mention which independent attribute, dependent attribute we would like to using that, and then we need to just somehow send the one data frame that not only has those data at the attributes, also has a one attribute, its name is const or whatever. So before just running that, for just showing you, if I just call that function, how it's working, it's going to add a one const with the number of 1 to my data frame. And this is my transformer that I explained. The entire transformer is that it's going to add the insert of at the first of column of mine, will add a one name, its name, it will add a one attribute, its name is const, and all of the value will be 1. That's it. So I'm going to just delete that, and I'm just fitting my linear regression with the dependent attribute of the sales and independent attribute of const, temperature, advertising, and discount. And if also I would like to just, once I fit that, it will be, I just would want to just know about the summary of that. My summary, the R square value based on my data frame is a high number, 94%, which is a good number. And if you would like to check also, my model has a small value of the probability of a static, which is a good sign that my model is significant. And also the p-values also show us that the model, this is something like a hypothesis test, which is not our concern, but for high level, the intercept value of R, it not has a significant sign for us. We have temperature, which is also temperature is not good value because it's 10%, and we are looking for the value, less than a 5%, and advertising and discount. But this is an OLS linear regression. And right now I'm not looking for the performance of my model. Right now I am just looking to have a one model can predict the temperature, predict the sales based on the temperature, advertising, and discount. And that's it. So let's just comment that one line as well. My model is ready. At the time that my model is fitted, this is a common function that's fitted. I just save it to another variable to my Python, which is my model is the thing that I would like to run it. And here, before running those piece of code, let's say I have one data frame, and model by itself, if I just predict that, it will be returned a sale based on the temperature of 42, advertising of 15, and discount of 5. It will be returned 19,590 point, some digits after. That's a predicted value that my linear regression just returned. But I would like to save that model and reuse it for next in other places or here in my Jupyter notebook. So I'm gonna go ahead, come back here, and I'm gonna show you. In the model folder, we don't have anything. And this is a time I'm gonna import my mlModelSaver, and there is a one class there that class needs to be constructed by the one configuration, the first configuration. For now, since the version that I show you during that video recording, you have to specify which base relative path you would like to save your model in your local file system. So I put ... That means I would like, right now I am in the notebook folder. I would like to come back to one folder top, and then which folder name do you want to use your model? I would like to use a models folder, which is the models folder here. So I will come back. That means that I would like to step back one folder from the current folder that I have. So I wanted to just use that folder, which is models, and just save my model there. And then once you have that construct, you instantiate one object of that class. There are methods there, which one of them is export a model. So you will be able to export your model. For exporting your model, you basically need to pass two arguments for that. The first one is the model, fitted model that is ready for prediction. So it's going to be this value, which is that the product of the fit model that you have. And then you need to send a one dictionary configuration. The dictionary configuration should have the model name, which is you can put whatever model name that you want, but do not put any space between. Do not start with the number and just use the normal characters, and then you can add a description there for making even my life easier. I just put the first the model name. Also, I put the description the same as. I can just put no description, but most of the time, whenever I'm just saving any variable, I will save some high level information. For example, this model has a predict sale by temperature, advertising, discount, and this is a fit. I put the fit at the end because I know that this model is fitted and ready to predict. The model type is important. As I mentioned, right now it's just supporting three of them: model, SMOLS, SMLogit, and the KNN from the scikit-learn. And then another one, you need to pass a list of dictionary for your input for your independent attribute. And the name is very important because most of the time the transformer that you will use, this one is very simple, but transformer that you will use, it's working with that name. So put that whatever name that you are looking for that, which is in our analyze is we are looking for the data temperature, advertising, and discount. So it's going to be my input. And the transformer, it's one of the important things. So the transformer, every model that you pass, you have to have one transformer, which is in this case, my transformer is just as easy as getting the data frame, create a new data frame, and add one column on top at the first column, and put the name of that const and put the value of 1 for that. So it's going to be my transformer. And the output that I'm expecting from my model is about sales, and the type is float. And whenever you export a model, it's going to save your model in your file system, and also it's loading that the way that it's going to be saved and loaded. And it will be return the object of the loaded model for you, and you can just use that. So I just put it here. If I just run that, as if I come back, you see in my model folder, one file which the format of the pickle just saved to my model folder, and have some kind of configuration of the current model, add some more method on top to just reusable for the future. So that model is just saved. And then I can just, the data, test data I just created is there. And whenever you load the model, it will give you one method, which is I explained, the mlModelSaver predict. And it will be able to predict your value. And the value that we predict here is just mentioned sales, and the value is just that. Okay, so it's just, I put some print also there. Let's just go ahead and fix that as well during the time that we are talking. mlModelSaver, my Python. Just use my Python. I think I have to just, no, it should be that one, but why it's not allowing me to? Let's just come here. I would like to just remove those one. mlModelSaver. here and init file. I put some print here, which is not makes sense. Yeah, I was debugging that. Let's just do it. So because I did, I just restart my kernel and I will run entire files, but it is return me the value the same as a value that we just using the original model, and but on top it gives me that it's return me back a list of predicted value by the value that has a key. So it also give us some more tools to be able to working with that. So please, if you have any question, I'm gonna just put my video to the YouTube as well. Here, if you have any question for the first example, feel free to just left a comment at that minute, so we can just discuss after. Another example. So before just going to the another example, our model is just saved here in this folder, and that's the thing. How we just discussed, we would like to just working with that model and serving it somewhere else. So in my README file, I put how we can just using our FastAPI. So the command to development of the FastAPI is that. So all you need to open another terminal, again activate your workspace, v bin and activate. And then just run a FastAPI command. And once you open the FastAPI, you see hello JSON is appear. And inside of that, there is a docs. So if I open that docs, and right now, because we have only one model, if I just call the list of the model, it just return me the only one single model. Okay, that's the model the first model that right now is in that folder. Okay, so it's looking to that the list of the files that, and it's assume as many model that we save is just show us that. And then we can just come here and put our model as a give us some information about the model. Based on the configuration that we just saved, it will be returned the same configuration that we did. For example, I just did not add any description there. So based on that, there is no description here. Just show us the OLS, temperature, advertising, and discount. That means if I want to just predict my value based on that, I need to just pass those values as well. So I'm gonna go ahead and come to another endpoint, and I will put my model name. I put some example here, and the example here is based on the value. But I do like to just use what we did from here. So the temperature is 42, 15, and 5. And I believe it's the same as here. No. 42, let's just put 42. Advertising. The first one was, okay, let's just copy that one. I'm gonna just copy that entire data object, and I'm going to paste it here and just execute it. The value that comes 19,590. And what was that value? That's the value. So if we feed the same value, because our model is the same model and it's everything the same, it will be return us the same value. And this is the FastAPI that I just run it to my local computer. But the FastAPI, once you have the project like a FastAPI, you can deploy it whenever you want, wherever you want. And there are millions of ways to deploy that FastAPI project somewhere. But I believe I just deployed that FastAPI project into one of my Heroku app. Let's just show you here. Okay. So basically, Heroku is the one place that whenever you have some web application and you would like to just serve it somewhere in a economic way, you can just create a one project, like as easy as that. Put your project name and just create some pipeline to just help you to just create it. But right now I have my ML project here, and my ML project is set it up, and the ml.json Jafari is attached to that project. and I can easily just deploy that. For example, if I right now, if I just show you ml.jsonjafari.com, and if I go to the /docs, the current list of the models that is there, it's basically 1, 2, 3, 4, 5, 6, 7 models there. But I would like to deploy the current changes that I did, okay? So if you set up the Heroku things, I put the README as well. And it's gonna be as easy as running that command if you are logging to the Heroku and do the configuration in your project. So I'm gonna open the one terminal and just put git push Heroku to the from the master branch that I am here. So I'm gonna just push that. Something wrong. Okay, I need to just, stage all of my changes first, and also commit that. Demo on video 1. So I'm gonna commit that my code, and then I'm gonna push the changes that I did. So once I push my changes, it's going to Heroku under the hood will go looking for my file configuration. It's going to install the all requirement dependency there. And then once it's ready, it just go and run a one single command line into that server to run the FastAPI project that is run to my computer. And it's going to be just push all of the files there. And because I already have the models folder and I did not exclude it, also those files will be deployed to that server. And it's going to be, my model will be presented there. As I told you earlier, for the next version of my app, I will give you an option that you can just specify the S3 configuration based on the environment variable that you would like. So at the time that you save your model is not saving, it's gonna be saved in your computer, but it's somewhere else. But at the same time, then your model is in the S3 bucket. So you don't need to deploy your model folder hack by your project to send it to the cloud. And it's already in the S3. And at the time that you need the model to just get a prediction, it's going to download it from S3 bucket, give it into your runtime, and you will be able to just fast running that. So my model is just released. That means if I just come back here, and it's this one. If I just come back, you see right now 6 model is there, but if I just call it again, it will be returned only 1 model because I just deployed it. And you see it's in my mlJSON project. Let's just refresh that and run it. You see it just returned one model because the other model is not there yet. So feel free, if you have any question, let me know. Another concept that it's important that I need to explain here in the FastAPI, I use dot, but in my Jupyter notebook that I show you, at the time that I instantiate the mlModelSaver, I put double dot. That is working with the, uPOSIX file system working. So if you put double dot, it's going to 1 folder. If you put double dot / double dot, it's going to 2 folder higher, parent. And if you put dot, that you are referring to the folder that your file is running. And in my main.py, my file is running in the root of the workspace of the project. So here I instantiated that one to the dot, which is that folder, and the molder folder is there. So be careful whenever you use that function at the time that you specify that. It's important to specify a good path for working. So in the use case of mine, I'm using a notebooks folder, so I will put double dot at the time that I'm saving the model. And for my FastAPI project, it's going to be at the time that I use that, because it's in the root of the workspace, I need to put 1 dot. Okay, I will go to the next example. I'm gonna close that, and let's just come back here home. And in the second example, I believe there is, I would like to have one more complex transformer. So the aim of that, I do like my data frame, if I might run my data frame. My data frame is, this one is a dependent attribute, and I would like to just predict my dependent attribute based on the independent attributes, which is the GPA, MIS, statistic. But also I would like to just, during my regression test, I would like to also, in my model, has an interaction between some of those independent values. So I will just show you the entire concept of that is about this. There is a transform for all interactions. That means here, this is a function. My data frame that I pass here, it will be created 3 more attribute. One of them is MIS, statistic interaction. Basically, it just apply a pandas, and based on the row, it will create another dependent attribute, which name is the MIS statistic, and it will be going to just add the rows and static. It's going to multiply them and just save them. The same for the GPA and MIS, and the same for the GPA and statistics. So that means your transformer can be a little bit complex. And at the time that you also want to feed your model to predict, that transformer also will transform the base data set that you send to feed to predict. It also can be useful. So for example, if I just run that as a I need to just, if I run the transformer for just give you some information here, it's just also at the end, because I would like to use a linear regression as well, I will add one const value at the first column of that as well. So if I pass my data frame, which is GPA, MIS, and statistic, it will be returned another data frame that has const, GPA, MIS, statistic, and all interaction of them. So at that point, I can just apply a nonlinear regression with the product of that I create based on my data frame, and it just transform what based on my specific use case. That in this case, I would like to show you the interaction. This is my transformation that is created. So let's just fit our model again, the model that I'm just going to fit, and after fitting, I would like to also just do the transformation to fit my model. And once it's fitted, I can just do the predict. Let's just do the save data, and it will be returned 73 based on those input. If the GPA of one user is 3.53, the MIS is 1, and statistic is 0, it's supposed to return the 73. But keep in mind, if you would like to just predict the data frame that you need to pass to the predict of the original value, also should be the data frame that the model is already trained by that, already fit by that. So we have to also just transform our test data frame, which is the test data frame by default will give those values. And for the original one, if you would like to predict, you have to just also call the same function or the same data object that already has those transformations. So it will be returned the 73. But let's just save our model. I will come back again. The file is not there, but I'm going to go ahead and run my model to save. And you see one other files also appear here, which is that files is just comp. The salary based on the GPA, MIS statistic, transform, MIS statistics. I just put some information into the file. And this is right now the loaded model is just returned. And if I just call the simple function that I create, if I return that value, it's return the salary with the 73 as well for me. Because it, under the hood, it basically do the same thing. First of all, is transform my data based on the data input that I provide, and then it's going to be predict the value for me. So that's going to be pretty useful at the time that you have a complex transformer, which is I have more examples there. So in this case, my transformer was a bit more complex than before. So it's gonna be show you to how you can interact with your independent attribute, and you just fit it as a non-linear way of fitting to the fashion to having using the linear regression for the nonlinear equation. And that's it. And if I come back to my FastAPI project, here, FastAPI. Yes, if I just run my document again and list of the model right now, because we just did another model there, that another model just appeared, and we can also reuse that model as well. I think I already created one Postman collection, which is, I don't know how can I share that, but maybe I can export it and I just put it as an example to the repository. But basically, instead of using the document of the FastAPI docs open API part, I created some endpoint and also I created two environment variables. If I come here, the mlModelSaver for my local development, just using that URL as an environment. As if I would like to use a live one, it's just using the my ml.jsonjafari.com. So the API call that I'm gonna just call, if I come back and you do the list, and if I just mention it, this my local development right now has 2, but if I go to the live one right now, it's only have 1 because we did it 1 and it's not there yet. So we didn't deploy the second model yet because we just fit it right now together. So I'm gonna bring it back here. I do want to just test that one. So I have that endpoint. If I just run the information, it gives me basically the information. I need to pass the GPA, MIS, and the statistic. And if I would like to predict, I think the predicted value the same as into here. Yeah, 3.53, yes. So if I run that, I need to looking for the some value like a 70%, 73.39. And I'm gonna call that, and you see it's going to return that value because just using that model. And even if I just deploy to my domain into the Kuroko server infrastructure, also can just work. It will give me the same result. Okay, let's just go to the next example. Because I provide some example, I would like to just cover them. This third one is basically, yes, whenever we would like to have a only one dependent value, dependent attribute that has, like, let's say the quadratic, whenever we would like, for example, quadratic regression model. So I'm gonna just run that. So basically, we have that data set. We would like to predict the wage based on the education and age. And I'm gonna just go ahead and run that. Let's just do some plots together. So here's the education based on the wage. The pattern between them is kind of a linear. So that's nothing. I'm gonna just hit that model and just create some linear line. But if we just want to just do the regression analytics for the relation between the age and wage, we see that kind of a, quadratic models here. So it's basically at the time that we would like to just using our linear regression, it makes sense to have another product which name is age power 2. Let's just run that. This one, if you just fit a one line, you see it's cannot just give us the good pattern for that, but we can create another transformer that just create the age power 2. That means we need to just create another product that we just multiply the age together like a power 2, or we can just use a math power of the Python as well. But in this case, I would like to make it simple. I just create that one. Basically, I am just creating them age power 2 by the way that multiply the age to itself, and it will be returned. And again, because we are going to use the OLS, SMOLS, we need to have another column at the first, which the name of constant has a value of 1. So here, if I have my transformer, and the transformer that if I call, basically right now I have the one data set that has const, education, age, and age power 2. And I can just, feed that model based on that. This is the same function that I call. And if I just call that for, high level information, it has the 83% coverage of the variety of my data, which is not bad. And, all of the p-values is good. And our model, it shows that our model based on that changes is significant. And also our p-value is small, and that's a good sign as well. So if I just want to just predict that those values just return me, but I would like to save my model. And before just save that, if I call that predict, why it's not working? Oh, I need to have a test data input. It will be return some value, something like a 17.97 with that value. So I'm gonna go ahead and just use my function to save that. This is a mlModelSaver. The name is that. The dependent attribute that we need. The independent attribute is education and age. And under the hood, the transformer will not only bring the education, age, and add a const, also create a one other data independent attribute, which name is age power 2 for us. And at the end, it will be return the wage for us. So I'm gonna go ahead and save that model. If I come back to my VS Code, that one also is saved. And then if I run that function, it will be return the same value for us, which is the original one, but as some kind of abstraction for us to help to not only give us the idea of what is the predicted value, and also you can just add multiple data. Let's just do something like that. If let's just do the first one. So for example, I would like to check someone has a 20 years of education and age of 55, for example. So if I just predict like that, it will be returned the second one like a 36K per year. But this one, it's also give us the one list of that has a better structure with every single value that comes based on the way it's coming. Feel free if you have any question for this one as well, just left a comment in the YouTube channel. And let's go to this one. What is that? Okay, this one is about to just show us another way of the transformation. I'm gonna go ahead and run that. Basically, right now we would like to predict the rent based on the bed, bath, and the square feet. And during our analytic, I believe we just run them fast. Oh, here. During the analytic, we found that the square feet relation with the rent has some kind of the flyer value. And those flyer value maybe can affect our analytic. And if we somehow can just do some kind of the transformation to just compress our data, it is something like log transformation. It's gonna help us to have a better model, linear model regression to fit that. So basically, if we just have a square feet, let's just go, but we can just create a log transformation. This is a scatter plot. Yeah. What if we create log transformation there? Not there yet. My code is not there yet. So just here. This is my transformation. The transformation here, basically, it is creating a data frame, and that data frame, it's basically will create another independent attribute, which name is log of a square feet, and just using the Python log, and just using the square feet created logarithm of the square feet, and it's gonna be saved that. And then because our right, let's just call that. That's gonna be help us. If I run this first, let's just run the transformer. If I run that, you see the product of that. The product of here, it has const and beds and also only logs, log of square feet. And why? Because at the time for our analytics, we just transformed our square feet with the log transformation, but we don't need to use the square feet for the fitting as another independent attribute. And our interest is only checking the relation between beds and only log square feet. Okay, so that's the thing, and that's it, our transformation, how it's working. And it's just creating the log transfer, and then it's going to remove the square feet from our main data attribute, data frame. And after that, I can just fit one model. And because my model is ready, so I'm gonna go ahead and save my model. And for the saving my model, it's used the same as what we did. The name, the model, the name, it is based on the bed. And this time it has the attribute is an integer because it's not float. And square feet is integer as well, but keep in mind, we pass a square feet, but our model is looking for the log of square feet. And the beauty of that, the transformer will do entire things for us, and it's going to just run that. So before saving that model, let's just do the test. I'm gonna run that file, and I will just use the original value with the same transformation. It will be returned the rent, the log of. So let's just come back. Here also, we created one other data attribute that we are also using the logarithm of the rent. This model is based on that, and it is working the log of rent. So at the time, it's going to be the logarithm of the rent. Let's say the rent is 6 million, and the logarithm of that is going to be 2000 because it's going to be compress my data. So if I just have that data frame and I just pass the original model that's not saved yet, it will be returned a 6.88 for me. And if I save my model and just reuse my model, just predict, it also return. But here also give us a good information. The value that is returned, it's not the rent that you predict, it's the logarithm of the rent. The product of the logarithm of rent, it's supposed to be 6.88. Again, this one for the fourth example. Feel free if you have any question, reach me into the YouTube channel. And let's just do that for the one linear regression, how it looks like. So if I run that for the linear logistic regression, here basically we have the data frame that that data frame was about that let's say one bank wants to give a loan to some users for buying house. So the first value, I think it's a source of income, and second value, I don't remember what was that, but so there are two parameters like a independent attribute, and we would like to get a binary classification probability that how that how we can just make a decision based on that. Okay, so the logistic regression basically working with the linear probability model and the logistic regression as well. So I will just did my analysis here. If I just create some chart, it's going to show me the relation between x1 and y, and also x2 and y. And we can easily for doing that also logistic regression, we need to have a transformer. The transformer is the same as the transformer for the linear regression. And we need, because we still is using the SM logit, we need to also have the one constant value as a 1 and insert those value. And once I just have that transformer and just use that transformer and fit my model, it just return. I'm not saving that. If I get that value and just predict it by the original value, basically it will be returned the probability value. And that's going to be the probability value. It's going to be the different analysis for the binary classification, validation, and things like that. But for high level, if we assume that our cutoff value is 0.5, that means this predict it's eligible to getting the loan, because based on our analytics and the cutoff value that we put, that something like that is going to be the product of that. But it's not a matter of that file that we just did discuss. I'm going to go ahead and save. For saving that, the logistic regression, we need to put SM logit, because we use that model for that and the fitted value, and we need to specify which input that we are looking for, which output, and the output of Y. Whenever you use the binary classification based on what I created one thing that I put that value is a probability. So at the time that you call that endpoint to get the information, you know that the value is returned, it's going to be a probability value. And if I just save that, the original value is 0.83, and if I call the Y also, it's going to return me the probability value. So again, for this logistic regression, also, if you have any question, just leave a comment. And the last one, I have a KNN, which is nearest neighborhood. There are lots of things. I'm not going to just teach that. I'm going to just, looking for the option that we can save that KNN. So I'm going to open, load my data frame. Let's just go. Okay, here, that's an important piece for the KNN. For the KNN, if you would like to have a good analytics for the nearest neighborhood, we have to somehow either normalize our data or standardize our data. And that's the things, that's one of the challenges for those models that transformation based on the normalization or standardization. If you have that kind of challenge, and if you save your model, at the time that you would like to predict, you also need to have the same function that you did for transformation, because for the standardization, you need to know about the standard deviation, you need to know about the mean value, mode value, and so on to just recreate that. Or for the normalization, you need to know about the minimum of the original data, maximum of the original data, and just create a normalization. And also, which type of normalization do you want to use? Is that between 0 and 1, or is it between -1 and 1? And so that's an important piece that you need to know about it. And this one can be achieved by the way that I create. You can save our transformer as another object that we pass to our transformer. So what I create here, basically I just use a standard scaler for standardizing all my data with the Python and the libraries here from the scikit-learn pre-processing. And before creating the transformation function, I just use the standard scaler, and then I transform my original data and just fit the transformer, that the transformer learn how to transform the data. So I just did it for the age, for income, and hours. And our goal is to just standardizing value and fit the KNN model to just kind of predict the enroll. And we can, in theory, fit the age, income, the original, and hour to the kernel, but because the distance between each nearest neighborhood that we are looking for, maybe one of the independent attribute will just get the entire portion of looking for that analytics, and it's not give us a true prediction and true classification, true nearest neighbor, the neighbors of those value that we are looking for. So we have to just do either standardize it or normalization. So before you creating, it's going to be one of the practice. So let's say I create a one model for only standardization, and I just create for a scalar age, scalar income, scalar hours, and so on. So I just fit those transformations, and then I just create a one dictionary that I am saving those internal transformers. Okay, the internal transformers that I would like, I'm gonna just pass the scalar age, scalar income, and scalar hours, and I just pass a key, and as a value I pass the Python object of the transformer. And then I created another transformer. I name it transformer step one. And the transformer step one basically will allow us to put the two parameters as a argument. One is going to be a one dictionary of contain those values and also the data frame. And it's just doing the same thing. It's going to copy that data frame, and then it is going to just create a one data frame independent attribute based on my analytic. I put the scalar age, and I'm using the internal transform, which is once I'm calling, I will pass that one. And that one has a one key, which name is scalar age, and I will do the transform my entire data set to that. So it's going to be transform the age for me and return it to that value. The same for the income, I will use that for the income transformer, and also I will use for the scalar hour for that transformer. And then, because my transformer is supposed to just transform and just, return me the only those value, I'm gonna drop the age, income, and hour as my transformer. Okay, but the way that transformer is there, we need to somehow send that transformer at the time that we call it. But the way that I create the mlModelSaver, basically the mlModelSaver under the hood at the time that we send, it's just feeding the data frame. And it is not something that I will be able to also pass the internal transformer to that. So for achieving that, we will come back to the beauty of the Python and beauty of the Python community. There is a one Python module which name is function tools, and the function tools basically can create another function for me as a wrapper that if I and they said there's a method which name is partial. If I just use the partial and use the original function and pass the value that I would like to use that, I will be able to pass that, and it will be return me another function, which is that function right now can only accept the data frame. So I just, remove the first input. Basically, I call that function, I remove the first input, and under the hood, it will be called that everything for me. So I pass that, and I have right now one transformer that this time this transformer only accepts the data frame. And under the hood, the all internal transformers is inside of that. So it can give us the good tools that we can just combine those things together to have a one general transformer for also achieving the KNN or the similar model that we need to sometimes do the transformation during the call. So that's a good practice here. If I just run that one, let's just come back. I want to run it again. Just restart the kernel. I'm going to run that transformer here. So internal one, I'm going to just create the transformer, with the only that one. So right now I have a one transformer. If I just run the transformer like that, basically it will be returned. If I pass the original data frame, it will be passed the scalar age, scalar income, and scalar hour. And the value is between some minimum value minus minimum value and maximum value, and the standard deviation of that value is 0. So that's going to be help us to just do our KNN analysis. So for achieving that, I will just go ahead also, add those values to my original data frame based on that data frame, and then also create a one categorical values based on the original data frame. The enroll one, it's 1, 0, and 1, but KNN, whenever you would like to send a KNN, you need to just ensure that the value that you fit to the KNN is also categorical. So once I create that, basically the product of that is going to be the enroll, age, income, hour, which is the original one, but has a scalar age, scalar income, scalar hour, and enroll categories. So I would like to just fit the KNN class, KNN the method for just fitting and getting that one as a model. So basically, I will create a one list of my independent values, which is I'm looking for the scalar age, the scalar income, and scalar hours, and also the dependent attribute that I am looking for the predict is the categorical value of the enroll. So I'm gonna go ahead and run that. And here you need to just do some train and testing. The algorithm like KNN, you need to just do the cross validation or validating that. So basically for creating that, we need to just first just do the train and split our data set to the train and test. So the split basically it's going to be 40% test size, and also I use the random state because the algorithm for training and splitting the training and test, if we do not put the random state every time that we call, just do the randomization under the hood. So it will be returned a different value, and I don't want to getting the different value. I would like to every time that I run my analytics, like having the sum, getting the same result. So we can easily specify the random state. That random state can be at whatever value that you would like. And also there is a way that there is also things that which random state is good for your model, but it's not the part of our concern for this one. So I will just do the training and test model. So right now, if I'm just looking for my training data, basically my training data also has this scalar age, scalar income, and scalar hour. And then I'm going to just use the KNN classifier, and I will put the KNN classifier for K, just looking for the K between 1 to 11, between 1 to 10, and also do the cross validation, K full cross validation with K of 5. So there are 2 K here. The one of the K is that just looking to just give me the best K of the KNN, which nearest neighbors, if I'm relying on that, I will get a better value. And also the cross validation, K full cross validation, it's going under the hood, do the cross validation, which K number is good for give you the best value. And then you can just do the fit. And once you fit that your KNN, there is a best score. If I just look into that, so the K for the near neighborhood is gonna be 5, and for the best cross validation value, the score was 91%. So, and also there is something like a result that we can looking for to that KNN analysis, which is also not our concern for now. But once we have, there is a best estimator in the KNN, and the best estimator can estimate something, and this is something that we need to save as a model for us. I mentioned it: Jim, enroll, age, income, hour, DF, KNN, fit, and I grab the best estimator. And the best estimator right now don't have a, it has a predict. Let's just to show you. If I call this function with my test set with the predict function, basically it's returns 0 or 1 for me. It's you under the hood, it just assume the cutoff of the 0.5. If it is greater than 0.5, predict is 1. If they're lower than the 0.5, it's assume it as a 0. But in the real world, it's the decision for cutoff value is a business decision, and it's not something the algorithm should think about it. So I think the KNN probability, we need something like a KNN probability value. And this one, let's just run. So it's returned a probability value of the, either true or false, but it's going to just give us the, two numbers. And the first number is about if case we are looking for the true positive, and only for the true positive things it's just going to true positive or true negative as well. So the first value is going to that, but the second one it assume that if you would like to using the true as a true positive, the false as a true positive. So that's the thing. And if you look into that, the value that comes here, that basically if this value is 0.8, another value is going to be 0.2. That means -1 that value. That means we only need to have a value of one of those values. And under the hood, my algorithm will take care of that for us. That means the predict probability value will return two values instead of one value. So if I just go ahead and just compilate my analysis, it just goes there. And there is a confusion matrix that based on the, true positive, false negative, false positive, and true negative that comes, and we can just, do calculation precision, recall, accuracy, specificity, sensitivity, and F-score, and so on can be done, but it is not our concern. And there is a AUC, the area under the curve of that, and also, do the ROC curve for us, but it is not something we are looking for. In the next generation of my things, I will just create something like a custom metric. I put something like a pseudocode here that the custom metric can save some information to the model, and at the time that we save that model, also we can have those information and we can just show that. But it is not there. One of the things that I'm going to work on that also is going to ensure that we can, at the time that save a model, also save some metadata that you can just reuse it for next, let's say 2 months after you would like to see your model get a prediction, you would like to know about some kind of the metrics about that, you can just save that. But now it's not just, I just create something and it is saving to my model. And if I would like to also access to that, the custom metrics will be available. And then we have an ML model. The model can export, but this time, whenever you would like to just using the KNN, you need to specify that model. Scikit-learn, neighbors, and KN neighbors classifier. And then you need to specify the original value and the transformer. But this transformer was a bit different than other transformers. Looking to the code that I create, that's to give you an idea. Then you need to have transformer, save the original transformer, and at the time that you would like to pass that transformer, you need to just use some kind of the practice like a functional tools, partial, and pass those values to the partial, and get a one final function. That function can just get the input of the data frame. And if I would like just do what we did before saving the model, let's say we have a data frame, and if you would like to just see the original value, it's the first result is 1, and the second one is 0.6. So I'm going to go ahead and save my model. And if I just run that, it will be returned the same value, 1 and 0.06. And the way that we just put for the KNN here, keep in mind the KNN, because it's returned two value for us. Also for the output, we need to specify the output like a 2 value. The first one is I put the indoor probability 1 and indoor probability 2. So it should be the value of the probability, and it's returned the probability 1 and 2 for us. So the KNN, if you would like to use for the output, you need to specify 2 attributes. And that's pretty much of it. And if I just come back, you will see we have right now 1, 2, 3, 4, 5, 6 model, which is 6 model that I just put as an analytic, and all is saved. And I would like to just deploy them also to my production value. But before that, let's just close all of my Jupyter notebooks and yeah, ensure that it's not changed. I'm gonna close out my Jupyter notebook, ensure that everything is there. So, and commit for, here we go. I'm gonna just commit that, push that, and also come back to my README and just do this one. So it takes a bit of time to just deploy. I will just a little pause my video and I will come back to just show you the final result. So, okay, pause there. We don't need to get to pause. It takes something like 1 minute. You can wait. Till that one is ready, please feel free to reach me. I will put into the YouTube channel, YouTube video, all the links that I use. And if you have a question, if you have some idea that we can make it better, for sure, I'm open to that. And notes that this one, it has some kind of abstraction to for the normal and easy one usage. And as I show you at the first step of the stage of the video, there are lots of tools around that can do the same thing and same achievement, but I did my best to just having the good level of abstraction that you can easily use that for kind of model saving and easily use that in a good way, in an easy way. And as you showed, that's not super much of thing. All you need to train your model, ensure that your transformer working as intended, and then pass the transformer and do the configuration, and then just serve it to your final application. So if I come back to my ML JSON Jafari here, /docs, and because it's just returned, all of the models is just there. Feel free to use that URL as well to just do the prediction for your site and see what is going to return your value. Again, thank you so much to watching that video, and let me know if you have any question. You can be in touch.